disseminate appropriate information to them based on their choices. Thank you very much, sir. So now we move on to practical demonstration of unsupervised learning, and we know that there's no other person to do justice to that than our one and only wonderful teacher, Dr. Sam, sir. Please, can you take us on practical demonstration of unsupervised learning? We want to see those codes.
Okay.
Thank you.
Good evening or good afternoon, everyone. So now we've been talking theories and all that. So we want to see a practical demonstration. So how do we cluster data in real world, like in the office, in industry and all that? So there are majorly different, many programming language that people use to do machine learning. So you can use R, you can use Java, but the most popular is Python. So for this demonstration, we are doing clustering with k-means using Python. And if you check the question is simply, we have a data set. So the flower data set. So, for some of you that did biology in school, you know that a flower has petals and sepal, as you can see on my screen. And the length, the width and the length of the sepal and the petal to a large extent is used to classify the kind of iris flower that we have. So now what will happen is that you're given a data set and you want to know how many categories or clusters of data you have in that data set. How do you go about it? You're just given the data set, but you don't know how many categories are present in that data set. As a data scientist, how do we go about to know how many data sets, how many type of flowers we have in that data set, and then be able to classify them appropriately? So to do that, as usual, we import warnings just so that we don't get annoying messages from Python. And then we import all the necessary modules that we can use for our analysis. So in this case, we are importing, you keep hearing people say models, algorithms. An example of it is the k-means. So we are importing this algorithm or modules or these models from the sklearn. And then we also import, remember we talk about pre-processing. That means we get our data, we still need to process it so that the machine learning can understand that data better. So we use the main mass scaler. So we just kind of scale it down between 1 and 0. And that's exactly what you see here. So I'm going to run that. And so the task is that we are given a particular data set that contains all the length and the width of both the petals and the sepal. Of course, you know what petal and sepal means now. So we import the one again, and then we import the data set. So the data set will load it from the iris data set that comes automatically with most of these machine learning models. And then we convert it to a table form. And as you can see, this is what we have. So we have the length, the sepal length, the sepal width, the petal length, and the petal width. And we have about 150 of them. And then they say we should classify them into categories. But we don't know what categories we need to classify them. And so the first thing we do, just like we see here, is that we check the data set, and exactly this is what we have. This is the only thing we have in our data set. And we are asked to group it based on this data that we have into the different kind of flower, iris flower that we have. And to do that, the first thing is to scale our data. To ensure high accuracy, we need to scale that data. As you can see, we transform that data by making it between 0 and 1. And so when we run that, this is what we have. And then by the time you check the scale data now, let me just run it live so you can see it. So you check that scale data, everything is now between 0 and 1. So that means our machine learning will now be able to identify that data correctly. As you can see, this is what we have. We'll be able to scale our sepal length and all that as it should be. Now that we've done that, the next thing we do is simply to plot the graph. So typically for you to know what kind of categories of data you have, classification or clustering you have to kind of check this data. So now, when you check this is what we have. Now, we have, okay, sorry about that. Better. Okay, let me run down. About that. So we take this data set. That's not what I want. So let me just choose this. Okay. Then we run. And this is what we get. And you see, we get this kind of relationship, which is typically the pattern. So we get this kind of relationship. We see from here, you see that this is the length. This is actually supposed to be the petal length. And then this is the petal width. And if you look at this, you will notice that from seeing this graph, the only thing we can see is two classification. So sometimes it could be misleading. So when you have that kind of scenario, what do? You do further checks. So mere seeing it says two, but it may not be the case. So what we do is we run a series of check. And one of the series of check, we check whether to know how many cluster actually is this data set. One of it is the elbow method. And so we create the graph using this code, and then we plot it. Now, when we plot it, this is what we get. We get this kind of graph. Now, from this graph, you will notice that the elbow point is at 3. But sometimes some people can say, no, it could be 5, it could be 4. So what we do is we run further check. And when we run further check, we run what we call the Arabas metrics. So when we run the Arabas metric, it gives us the correct value. Can you see? It actually tells us that it is 3. So we've run 2 checks now, and we've confirmed that the number of clusters we have in this flower is actually 3. And so because we now be able to confirm decisively that the number of clusters we have, remember the pluses look like 2, but in real world it's actually 3. And that's exactly what you see here. Now that we've identified that we have actually 3 clusters, we now specify our cluster. So we'll be able to identify our clusters, then we can now apply our machine learning on that number of clusters. And when we apply our machine learning, just like we mentioned, they always give us answers in numbers. So we have 3 classifications, 0, 1, and 2. And now that you have given us that answers that we need, all we need to do is simply to add our prediction. So it's able to say, okay, based on the length and the weight of the sepal and the petals, it's able to classify these flowers into 0, 1, and 2. Remember, we don't know what the output is, but we know that they can be grouped together under a category. Let's say category 1 is 1, category 2 is 2, and category 3 is 3. And when we do that, we add the prediction, which is now the clusters that we'll be able to create into 0, 1, and 2. Now that we've created that, we can now plot our graph to see how it looks like. And this is what we have. Can you see now that we've plotted our graph? You see that it can clearly demarcate that this is one cluster, this is another cluster, and this is another cluster. So we have 3 different clusters in this our result. And now that we have 3 different clusters, then we can conclude that actually in this 450 types of flower data that we have, they can be successfully grouped into 3 categories: the black category, the red category, and the green category. Remember, we don't know what they are, but based on the length of their petals and their sepal, we can be able to group these flowers. Now, the next thing is actually we know what they are. And people who actually did the experiment, who took the data, already told us that there are actually 3 different samples. And the names of the flowers are actually Iris versicolor, Iris setosa, and Iris virginica. So you can see now that based on K-means, when we don't even know what the number of clusters or classification of our data is, we can use machine learning to guess what the eventual number will be. And from here, we'll be able to guess that the eventual number is actually 3. And now, we've tested it against what we already know, that from the actual target, which is actually when you decide to use this as a supervised learning, we actually have 3 types of flower. And the name of the flowers actually is Iris versicolor, Iris setosa, and Iris virginica. So these are the 3 types of flower we have in our data set. And that's exactly summarize how we, as data scientists, are able to use machine learning to predict clusters of data, even without knowing what they are. And that's exactly the result of what we have. And with that, we officially